Hello students, we are here to discuss about the new chapter which is the motion in plane and uniform circular motion. Motion in plane, we will discuss about the position vector, displacement vector, velocity and acceleration in plane. Means we have to find their components along x-axis and along y-axis, means their rectangular components. We have to write the velocity and acceleration in terms of their components. There are two type of the velocities and acceleration. One is the average and second one is the instantaneous. In case of instantaneous, we take delta t tends to 0 and delta x upon delta t becomes derivative. Delta changes into the derivative. After that, we will do some numerical based upon these topics and do a new topic which is the projectile. Projectile is an object is projected into the space with some initial velocity and it fall under the gravity alone. Means you have throw a stone from the certain height at an angle or the horizontally. Example, a bomb is released from the aeroplane. Bullet is fired from the gun. These are the examples of projectiles. Projectiles are of two types. One is the horizontal projectile and second one is the oblique projectile. Horizontal projectile, you project an object, you throw an object horizontally. Oblique means you project an object at an angle theta with the horizontal or with the vertical. So let us start. First we will do the position and displacement vector in plane. Position and displacement vector in plane. To do this, we have to consider a system of coordinate x-axis, y-axis. O is the origin. Suppose at any time t, the particle is at point P, whose position vector, whose coordinates are x1 and y1, and r1 is their position vector. Now, after some time t2, the particle reaches at point Q, whose coordinates are x2 and y2, and position vector is represented by OQ, which is the r2 vector. Now, P2Q, you draw a vector which is called a displacement vector. Now, first of all, to write a position vector, OP vector, that is the R1 vector is equal to x1 I unit vector plus y1 j unit vector. And at time t2, the position vector is represented by OQ, which is R2, and can be written as x2 I unit vector plus y2 j unit vector. In the order to find the displacement vector, we have to apply the triangle law of vector addition. According to the triangle law of vector addition, r vector plus delta r vector is equal to r2 vector. Triangle law of vector addition states that if the two vectors are represented both in magnitude and direction by the two adjacent sides of the triangle, then the resultant will be given by the closing side of the triangle. So we get delta r is equal to r2 minus r1. Putting the value of r2 and the r1, we get delta r is equal to x2 plus x2 I unit vector plus y2 j unit vector minus x1 I unit vector plus y1 j unit vector. Add or subtract the component of I and the component of the j. We get delta r is equal to x2 minus x1 I unit vector plus y2 minus yj unit vector, where delta r is equal to delta x I unit vector plus delta y j unit vector. To find the magnitude of the displacement vector, since delta x and delta y are the rectangular component, so the angle between these two is 90 degree. The resultant will be given by square of the magnitude of the first component plus square of the magnitude of the second component plus magnitude of first component, magnitude of second component into cos of angle between these two, which is the 90 degree. Hence we get delta r is equal to magnitude of delta r is equal to delta x square plus delta y square under the root. Putting the value of delta x and delta y, we get x2 minus x1 whole square plus y2 minus y1 whole square under the root. This is the displacement vector in a plane. Now we have to find the velocity of particle in plane. Again we have to take the coordinate system x-axis, y-axis. Suppose at any time t the particle is at point A whose coordinates are x1 and y1. And after some time the particle reaches at point B whose coordinates are x2 and y2. R1 and R2 are their position vectors. Now here there are the two type of the velocities as we know. There is the average velocity and the instantaneous velocity. Average velocity is delta r upon delta t, and when the time is very small, means delta t tends to 0 the delta r upon delta t is replaced by derivative of r with respect to the time. So write the component of the delta r, we get limit delta t tend to 0, delta xi upon delta t plus delta yj unit vector upon delta t. Separate these, we get velocity is equal to dr upon dt. As we know that when the time is very small, tends to 0, delta r is replaced by the derivative of r with respect to time. Now the component is dx upon dt I unit vector plus derivative of y with respect to time j unit vector. Dx upon dt is the component y component of velocity and dy upon dt is the j component of velocity. The average velocity can be found like delta r upon delta t, but the instantaneous velocity is given by taking a tangent at a point. The direction of instantaneous velocity is given by a tangent, right? To find the magnitude of the instantaneous velocity, we get vx magnitude of vx square plus magnitude of vy square under the root. And as we know that again the angle theta is 90 degree, which cos 90 is 0, and hence it becomes only vx square plus vy square under the root. Now uniform velocity in the two-dimension motion. What? You have to find the expression for the uniform velocity in two-dimension motion. Means we have to derive the formula for the uniform velocity. As we know that v is equal to r2 minus r1 upon t2 minus t1. Suppose at time t1, initially a particle is at rest. Initially the particle is at the position r0. At any time t2, which is equal to t, r2 is taken as r. Put the value of r2 as r, r1 is r0, t2 is t, and t1 is 0. We get r minus r0 upon t, where vt is equal to r minus r0. Now the component of the velocities, as we know, vx I unit vector plus vy j unit vector, and components of the velocity r is equal to xi unit vector plus yj unit vector. r0 can be written as x0 I unit vector plus y0 j unit vector. We are putting these values, we get t into vx I unit vector plus by j unit vector is equal to xi unit vector plus yj unit vector minus x0 I unit vector plus y0 j unit vector. Now comparing the I components and the j components. First of all, equating the I component and j component. After that, compare these components. We get vx I unit vector plus vy j unit vector into time is equal to x minus x0 I unit vector plus y minus y0 j unit vector, which is equal to, on the comparing, t into vx is equal to x minus x naught and t into vy is equal to y minus y naught. X is equal to, this equation can be written as x is equal to x naught plus vx into t, y is equal to y naught plus vy into t. This is the uniform velocity in plane. Next we have acceleration of particle in plane. Acceleration, we know that there is also two type of acceleration. One is the average acceleration and second one is the instantaneous acceleration. Average acceleration is equal to delta v upon delta t. When delta t tends to 0, the delta v upon delta t is replaced by dv upon dt, which is the instantaneous acceleration. Now, we know that v vector can be represented as vxi unit vector plus vyj unit vector, and a vector becomes, acceleration becomes dvx upon dt I unit vector, dvy upon dt j unit vector, and dv upon dt we know that acceleration. dvx upon dt is the x component, dvy upon dt is the y component of acceleration. So it becomes a is equal to axi unit vector plus ay j unit vector. The magnitude of the acceleration can be found by squaring and adding the components of I unit vector and j unit vector, and they take the under root. Here ax can be represented by dvx upon dt, ay is dvy upon dt. As we know that vx is dx upon dt and vy is dy upon dt. So acceleration becomes second derivative of displacement of x, and with respect to time, ay becomes second derivative of y with respect to time. D square x upon dt square is called second derivative, right? Next we have uniform acceleration in two dimensions. Acceleration, we have to find the uniform acceleration. A is equal to v2 minus v1 upon t2 minus t1. Let a particle is moving with velocity v1 and v2 at any time t1 and t2 respectively. Put t1 equal to 0, t2 equal to t, and v1 equal to v0, v2 is equal to v. We get acceleration is equal to, this is the acceleration, is equal to v minus v0 upon t minus 0. V can be written as vxi unit vector plus vyj unit vector. v0 can be written as vx0 I unit vector plus v0 y j unit vector. Putting these values, we get at is equal to vxi unit vector plus vyj unit vector minus v0 xi unit vector plus v0 j unit vector. Now equate the I component and the j component and then compare these. By equating the components, we get axi unit vector plus ayj unit vector into t is equal to vx minus v0 xi unit vector plus v0 y minus v0 yj unit vector. Now compare these factors, these components, we get ax into t plus vx minus v0 x ayt is equal to by minus v0 y. Position coordinate of the particle in plane are 1, 1 and 2, 3 at the time t1 and t2. What are the position vectors of the particle at time t1 and t2? And what is the displacement of the particle during this time? First of all, we have to find the position vector, that is r1 and r2. r1 can be written as x1 y1, x1 I unit vector plus y1 j unit vector, that is I1 I unit vector plus 1 j unit vector, which is equal to I plus j unit vector. R2 can be written as 2I unit vector plus 3j unit vector at time t2. Now displacement of the particle delta r, which is equal to r2 minus r1. r2 is 2I unit vector plus 3j unit vector, and r1 vector minus I1 unit vector plus j unit vector. Delta r is equal to I unit vector plus 2j unit vector. The magnitude of delta r can be found by squaring the components and taking them under the root. That is, under root square of the component of I, which is I square, plus square of the component j, which is 2 square, and we get under root 5 units. Next question, the instantaneous coordinate of the particle are x equal to 5t minus 3 meter and y is equal to 7t square. Number 1. Calculate the average velocity of the particle during the time interval from t equal to 1 to t equal to 2 seconds. And second, find the velocity of the particle at time t equal to 2 seconds. First of all, we have to find the average velocity, and the formula for the average velocity is delta r upon delta t, which is r2 minus r1 upon t2 minus t1. Means you have to find the value of r2 and r1. r2 value can be found by putting the t equal to 2 seconds. r1 can be found by putting the value of t is equal to 1 second. r1 and r2 can be written as, first of all, x is equal to 5t minus 3, y is 7t square. At time t equal to 1, x1 is equal to 2, y1 is equal to 7. Put the t equal to 1 here. At t equal to 2, x2 is 7 and y2 is 28. Now, putting the value of r2, r1 and r2 becomes, r1 is equal to 2i plus 7j, r2 becomes 7i plus 28j. On putting these values, we get V average is equal to 5I unit vector plus 21j unit vector upon 1 second. And we get 5I plus 21j meter per second. Now, velocity of the particle, that is instantaneous velocity of the particle. Instantaneous velocity can be found V is equal to delta x upon delta t I unit vector plus delta y upon delta t j unit vector. Delta means here derivative of x with respect to time, derivative of y with respect to t. Find the derivative of x. Derivative of x is here 5, only 5, right? And 3 is a constant, so derivation of the constant is 0. Now derivation of y, 2 is multiplied with the first term and reduce the power on the t by 1. So we get 14t. Now 5i plus 14tj, at t equal to 2 seconds, it becomes 5i plus 28j. The magnitude of the velocity can be found by squaring all the component and take them under the root. We get 5 square plus 28 square, which is equal to 809, right, unit. Next we have projectile, a body which is thrown into the space with some initial velocity and then allowed to move under the influence of the gravity alone is called projectile. The path followed by the projectile is trajectory. Example, a bullet fired from the gun, a bomb is released from an aeroplane, right? There are some assumptions when we discuss the problems on projectile. Number 1, no resistance due to the air. Second, effect due to the earth curvature is negligible. And third, the effect due to the rotation of earth is negligible. Type of projectiles, horizontal and oblique. Horizontal projectile, first of all. Horizontal projectile, a projectile is projected from the certain height. A projectile is projected from a certain height horizontally with the velocity u, which is falling under the gravity also. Suppose at point P, its component are x and y. So we have to discuss the motion in 2 dimensions. One is the horizontal and one is the vertical. Along horizontal, x is equal to x naught plus uxt plus half axt square. Since x naught is equal to 0 initially, ux is equal to, ux means velocity along x-axis, which is equal to u. Since the velocity is uniform along the x-axis, so the acceleration is 0. If we have the velocity uniform, then acceleration is 0. Because uniform means constant and derivation of the constant is 0. क्योंकि acceleration जो होता है वो derivation of the velocity होता है. X equal to 0 ut plus half of 0 t square, that is x equal to ut and t is equal to x upon u. Along vertical, y is equal to y naught plus uyt plus half ayt square. Initially y naught equal to 0, uy equal to 0 because projectile is projected along the horizontal, not the vertically. Since the projectile is fall under the gravity, so acceleration is equal to taken as g. And putting this value, we get a equal to gt square. Put the value of t from the above, we get g is y equal to g x upon v whole square. That is y is directly proportional to x square. Whenever you get y is directly proportional to x square or x is directly proportional to y square, this is the equation for the parabola. Hence, the path is parabolic. Right? Next, we have time of flight. Time taken by the projectile to complete its trajectory is called time of flight. Let t is the time of flight and h is the vertical height. Vertically downward motion. Y is equal to y naught plus uyt plus half ayt square. As we know that y naught is 0, uy is also 0, ay is g and small t is capital T, which is the time of flight. Y is taken as h. Now putting these values in the equation, we get t is equal to 2h upon g under the root. Next we have horizontal range. It is the horizontal distance traveled by the projectile during its time of flight. X is equal to x naught plus uxt plus half of axt square. When we find the time of flight, we take the vertical direction, motion along vertically, and when we find the horizontal range, we take the motion along horizontal. X naught is 0, ux is equal to u, ax is equal to 0, x equal to r and small t equal to t. Putting these values, we get r is equal to u into under the root में 2h upon g. Now we have to find the velocities of the projectile at any instant. We know that velocity Vx is equal to Vx naught plus axt along the horizontal. Vx initial velocity is u, acceleration along the x-axis is 0 and Vx is u. Vx equal to u by putting these values. For the vertical, Vy is equal to V naught y plus Ayt, V naught y is equal to 0, Ay is equal to g, Vy is equal to gt. And velocity is equal to square of the x component of velocity plus square of the y component of velocity. We get u square plus g square t square under the root. Direction can be found by the tangent of the angle, which is Vy upon Vx is equal to gt upon u. And the last, we have to find the velocity of the projectile when projectile hit the ground. When the projectile hit the ground, the time taken by total time is time of flight, which is taken during the vertical motion. And the horizontal remain Vx equal to u, Vy is equal to g into under the root 2h upon g, which is 2hg. By finding the magnitude Vx square plus Vy square, we get u square plus 2gh under the root whole square under the root. Means V is equal to u square plus 2gh under the root. That's all for today. If you have any doubt, you can call me. Okay, thank you, beta.